Now, we will discuss about what are the limitations of human vision in darkness. Vision, the ability to see, is an effect of the interaction between brain and eyes which uses light reflected from objects from surrounding. Human vision depends on light in the visible spectrum between 400 nanometers to 700 nanometers as our eyes are designed to detect and process this range of electromagnetic radiation. However, this limitation of human vision in darkness are obvious when there is no visible light as human cannot see totally in the dark or in environment when there's only non-visible light such as infrared and ultraviolet. Firstly, dependence on light for vision. Human eyes depends on photoreceptor cells. Photoreceptors are cells with high metabolic activity, so they are located near to choroidal blood supply. There are two types, which is rods that are responsible for night vision, as known as scotopic vision, and cones that are responsible for daytime vision, as known as photopic vision. When there is no light, cones become inactive. Rods will take over human eyes, although it cannot function effectively in complete darkness. In the dark, rods cannot provide colors and sharp details, but it can help detect shapes and movement. Secondly, limits of dark adaptation. Dark adaptation is the ability of the eyes to adjust to low light or darkness after being exposed to bright light. It is found that recovery can be very slow and taking many minutes. A full dark adaptation involving 100% rhodopsin regeneration and takes approximately 50 minutes.
Number 3 is inability to see complete darkness. Without any external light, example from the stars or moon, there is no visual input for the eyes to process. As a result, human cannot perceive anything in total darkness. The biological limitation of the photoreceptors, especially the inability to detect any ambient light, and lead to a complete absence of visual information.
I will be talking about the physics principle behind the technologies that enable us to sense or visualize in the darkness. Firstly is sound navigation imaging, also known as sonar. Sonar works by transmitting sound wave at ultrasonic frequency and analyze the wave that returns after the pulses are reflected off the object. The maximum frequency range of sonar is 1 GHz. Sonar wave reflects off object with the strength and shape of echoes depending on the object size, shape, and material. Two types of sonar, which is active sonar and passive sonar. Active sonar spread wave and then absorb the reflected echo, while passive sonar cannot spread wave but only absorbs. Next is infrared. It is based on a physical phenomenon where any body with a temperature above absolute zero emits electromagnetic radiation. You must ask, how does the infrared machine work? When heat is released as infrared radiation, the machine will pick up, and the different amount of infrared radiation is translated into other visible light. When a heated molecule vibrates, they move quickly around any charged particle such as electron. The charged particle will produce electromagnetic radiation. Therefore, the moving molecule will cause glowing from the heat.
The physics principles behind LIDAR. LIDAR is also known as light detection and ranging. It uses a remote sensing method which allows humans to examine the surface of the Earth. It uses light in the form of pulsed laser to measure variable distances to the Earth. Combined with other data recorded by the airborne system, it can generate precise three-dimensional information about the shape of the Earth and the characteristics of its surface. Coherent LiDAR measures the velocity of moving object by using Doppler shift of light, which allows exceptional depth accuracies. Many autonomous vehicles have applied this technology because of its accuracy.
I will be talking about the application of this technology in real life. First, infrared imaging was used in surveillance camera to allow camera to see in low light conditions. Next, thermal imaging was used in long-range thermal images for ground troops to detect enemy forces. While sonar was divided by two, which is active sonar to map sea floor and passive sonar to detect sound underwater. Lastly, LiDAR was used by scientists to derive vegetation structure. That's all from us. Thank you.